All right, so today we're going to talk about square roots. Finding or extracting a square root, okay? So, more importantly, a square root is really the opposite of an exponent that is squared. For example, 3 squared equals what? 3 times 3, which equals 9, okay? So what is the square root of 9? 3. So you ask yourself, what number can I multiply by itself to equal what is inside of the radical? Okay? That is square root. Okay? So what is the square root of the number 4? 2. You ask yourself, what number can I multiply by itself to equal 4? And that would be 2. What is the square root of 25? 5.
Hey, what's the square root of 1?
Okay, what is the square root of 36? 6.
No, what is the square root?
Okay, you guys teaching or me? Okay, we don't carry on our conversation. Okay, thank you. What is the square root of 49?
7.
7. Okay, what's the square root of 64? 8. What's the square root of 81? 9. That's how you find the square root. Now,
Well, but then there's going to start doing the square root of 3,000.
so you hear the term, Miles, please stop, guys. You hear the term perfect square. And that's what these are perfect squares. Why are they called perfect squares? They're called perfect squares because they have the perfect, I guess you could say, square root, meaning that they multiply by themselves. For example, 3 times 3 is 9. Okay? So if you have the square root of 12, that is not a perfect square. Why?
Because it's not one number by itself, it's multiple numbers.
Exactly. It would have to be 3 times 4. Something like that would have to be the square root of 12.
What would you call that?
That is answered, but you won't be using that is an answer, and that you can do it that way. But that's not the way that what we're going to be doing. Let's quickly look at a fraction. So let's say that we have the square root of 36 over 49. Okay? So what's the square root of 6? I'm sorry, the square root of 36. 6. What's the square root of 9? 7. 49 would be 7. That's your answer. That's the square root of that. Okay?
That's not as bad as I expected.
And you may see it written like this, the square root of 36 over the square root of 49, or you can write it like this.
It means the same thing?
It means the same thing. Yes, Ezra?
If you have 3 pairs of
Now, go to page 431 in your textbook. Okay? I'm just going to start a new page here. And this is where we're gonna begin now. Okay, so page 431. Okay, here we are talking about radicals. Okay, again, this is your radical symbol, as I told you. Some people do it like this, do a little flip or a little line and then up and then over. That's probably the more technical way to do that, but it depends on how busy you are. All right, so go to radicals there in the center, okay? Because we talked about perfect squares and a perfect cubed. But, well, let me back up here. A perfect cube, so we know a perfect square was the square root of 4 equals 2, okay? So a perfect square is a number of variable that is a product and has two identical rational factors, which are 2 times 2. Now, a perfect cubed is a number or a variable that is the product of 3 identical factors, okay? So a perfect cube would be, like I said, 3 of 27, because 3 times 3 times 3 equals 27, right? Okay, now you'll get that here in just a minute. So, look at radicals there in the center. I'm going to move on into this section because you guys picked that up real well. So, taking the root of a number is the opposite of raising a number to the power. In other words, it's the opposite of taking the number as an exponent, right? Page 431. So, the radical symbol we've talked about. So, the index indicates which root to take is located as a raised number in front of the radical. So, what is this right here called? It's called the index, okay? That's called the index. And you make sure you're looking at this with me on page 431. That is called the index. So the index indicates which root to take, and it's located as a raised number in front of the radical symbol, okay? They give you the example of 5 to 11. It has an index of 5. So next paragraph, same section. The square root of a number is a factor that, when multiplied itself, equals the radicand. Notice that, radicand. So, for example, the square root of 16 is 4. Since 4 times 4 is 16. Likewise, the cube root is a factor when it's multiplied by itself 2 more times equals the radicand. Hush, pencil. For example, the square root or the cubed root of 8 equals 2 times 2 times 2, which equals what? Equals 2. Okay, so that's saying that the cubed root of 8 is 2. In other words, 2 times 2 times 2 equals 8, right? What would you call the 4 if you had a 4? This is called a 4th root. Okay, so you have the square root. Let's clarify that. You have your square root like this. This is just a square root. Hope you're paying attention. Then you have a cubed root. And then you have a 4th root, which is F-O-U-R-T-H, right? In other words, whatever the radical number is on the inside can be multiplied by itself 4 times. Or it's multiplied 4 times. You know, you can even go the 5th root, the 6th root, the 8th root, and so on. Okay? Which makes it even a little harder, and that's why I think that you guys are ready to move on even further. So, now, go over to page 432. Page 432. Okay, so now finding a rational root. Right, Bear? So for any root not to be rational, the radicand must have the same number of identical factors as the index. For a square root to be rational, the radicand must have the perfect square, such as the square root of 144 is 12, right? So the cubed root needs to be the same 3 numbers. The 4th root needs to be the same 4th numbers, and so on. Okay? So, now, To find a rational root, express the radical using a fractional exponent and reduce the exponent. This is really what I don't want to get into quite yet because I don't, we're not ready to use fractions as exponents with square roots, okay? So, here's what we're going to do, folks. So go over to page 433. Page 433, okay? Now, we're going to do 1 through 12 together, okay? Because we're not going to use the variables. We're not going to mix the variables up in this, okay? So number 1, okay? So here's what I want to do. You're going to do some of this on your own, but most of it we'll do together. So we'll have 1, 2, 3, 4, 5, 6, 7, and 8, okay? So then we'll have our bases. Just bear with me. I know what some of you are doing. You're working ahead on me.
Oh, no.
You're not the only one in here, though, right? So base, square, and then cubed. Okay, so base is 1, 2, 3, 4, 5, 6, 7, and 8. Same as the number of problems. Now, so the square of 1 is 1 squared equals 1, right? All right, so what is 1 cubed? 1 cubed also equals 1. So what's the square root of 1? 1. What's the cubed root of 1? What's the fifth root of 1? 1. 1 is 1. All right, how about number 2? What is the square root, or what is 2 squared? 4. You writing this in your book with me? Yeah, buddy. What is 2 cubed? 8. Okay, what is in here's what you're doing. You're just doing 3 squared equals 3 cubed. So what is 3 squared? 9. What is 3 cubed? 27. In other words, 3 times 3 times 3, right? How about 4 squared? 16. What is 4 cubed?
48.
64. How about 5? 5 squared is what? 25. What is 5 cubed? 100 and what? 125. Winners in the back. How about 6 squared? 36. What about 6 cubed? 6 cubed. 6 times 6 times 6. Well, 6 times 6 is 36. Close. 216. 216. 7 squared. 49. 7 cubed. 343. In other words, you take 7 and multiply it times 49 because you've already got the cubed answer there. How about 8 cubed?
64.
8 squared, I'm sorry. 8 cubed.
512.
Good job. You're the winner there.
She owns them.
Okay, I'm just going to bring this up and continue going here. We're going to go down. We're going to go to the number 12, 9. So 9, 10, 11, and 12. So 9 squared.
81.
81. 9 cubed.
729.
Boom, you're the winner. 729.
Brain.
What else is in that?
I did do the math.
All right, 10. 10 squared. 100. What about 10 cubed? 1,000. You just add on your zeros, right? How about 11 squared? 121. How about 11 cubed? 1,331. So 12 squared.
144.
144. 12 cubed.
1,728.
Boom, you got it too. 1728.
Good job.
Now, in the next section here, I'll pause here for a moment. Okay, so the index is the square or cubed, and the radicand is what's on the inside. So number 18, our number is the square root of 121. Okay, so what is the radicand?
121.
What is the index?
11.
2. Because 11 times
I was right.
11 times 11 is 121, but that would be squared. So it would be 2. It's squared.
I am so
It's not the square root. You're not looking for the square root. That would be the answer. The index is the number that would be out here, and you don't actually put one there when you're actually doing a square root. Okay? All right, number 19. What is we have the 6th power of 64. So what is your radicand?
64.
Okay? What is your index? 6. Everybody see that? Because you'll need to know that. Number 20. You have... All right, what is your radicand?
625.
625. Make sure you're filling this in on page 433. And what is your index?
4.
4. You don't have a chart like I do. You have them individualized. I'm just writing them as a chart form just for fun. All right, number 21 we are going to do. And here we have a big old square root here. But it's not a square. It's the 9th root of 262,144. So what is your radicand?
2,601.
Okay, what is your index?
9.
9. Good job, guys. Now, let's do one more, which is number 22. And here we have the blank of 144. So, what is your radicand?
144.
What is your index? 2. Does everybody understand why it's 2 there? All right, because you know that 12 times 12 is 144, but you're not looking for the answer of the square root, okay? Now, let's just look at 23 together. Everybody got these down here from 17 to 22? All right, we're not going to do all of, we'll probably do 23 through 28 here, okay? 23, our question is, what is missing? What's missing? Right, because 6 times 6 is 36, so that's the square root of 36 is 6, right? All right, let's look at 24. What do we have? The square root of what equals 9? 81. Number 25 says the square root of what equals 2. So what is our answer? 4. Number 26, it asks us what the square root of 144 is, and that's what? 12. Our answer here is 12. Number 27,
11.
what is the square root of 121? And that equals 11.
11.
And lastly, number 28, what is the square root of 1? It is 1. Okay? Any questions on that? Huh? Uh-huh. Okay. All right, so first of all, you will definitely be having square roots along with the other components that go along with the radicals. In other words, you're going to be having, you know, your square root,
Okay.
Actually,
a cubed root,
what root always root from
fourth root. Yeah, your roots. Okay, I'm not going to go on any further, but you're going to be identifying just like we just did. We'll be practicing those tomorrow. Okay. Also, you're going to have 11.1, which is solving equations. You're going to be solving equations. Okay. You're also going to be 11.2, which is also solving equations. 11.1 did addition and subtraction. Solving equations. 11.2 is multiplying and dividing. Okay? You're also going to have 11.3, which is solving equations with 2 steps, I think. Yep. Okay. And then you're going to have 11.4. That is some word problems. There's not a whole lot of those, but there will be some.
Oh no.
There's
How many are there?
just a few. There are just a few.
Okay.
All right, and that will be it. Okay? The majority of this includes equations. Okay? So there are a few words.